Nonpolar bonding, or equal sharing of bonding electrons, occurs when the difference in electronegativity is 0.4 or less between the two atoms in a bond. This, of course, happens when atoms of the same element bond. Carbon and hydrogen are very common bonds, and it's important to remember that carbon-hydrogen bonds are nonpolar. Polar bonds, on the other hand, are unequal sharing of bonding electrons, and this occurs when the difference in electronegativity is greater than 0.4. Ionic bonding occurs when the difference in electronegativity is greater than 1.8. Bond polarity can be ranked, and the greater the difference in electronegativity, the more polar the bond. Usually, the farther apart atoms are on the periodic table, the greater their difference in electronegativity. Carbon and hydrogen are an exception to this. Let's apply the definition of nonpolar and polar bonds. Consider the bonds on this slide. Capital H singly bonded to capital F singly bonded to capital F, capital C doubly bonded to capital O, capital N singly bonded to capital H, and capital C singly bonded to capital S. Which bond is the most polar? Refer to the electronegativity values in the text and pause the video to answer the questions. To answer, we need to look at the electronegativity values in the text. When we calculate the difference of electronegativity values, we take the absolute value of the difference. So it's easiest to subtract the smaller value from the higher value. For the first example, fluorine has an electronegativity value of 4 and hydrogen 2.1. The difference is 1.9, so this is a polar bond, since the electronegativity difference is greater than 0.4. I've placed the delta positive symbol next to hydrogen since it has the lower electronegativity, and the delta negative symbol next to fluorine since it has the greater electronegativity. In our next example, each fluorine atom has the same electronegativity. The fluorine-fluorine bond is non-polar. There is no separation of charge. In the next example, the electronegativity value of carbon is 2.5 and that of oxygen is 3.5, with a difference in electronegativity of 1. Since this difference is greater than 0.4, this is a polar bond. I've placed the delta positive symbol next to the carbon, since it has the lower electronegativity, and the delta negative symbol next to oxygen. For the next example, the electronegativity of nitrogen is 3 and that of hydrogen is 2.1. With a difference of 0.9, this is a polar bond. I place the delta negative symbol next to nitrogen since it has the higher electronegativity value, and delta positive symbol next to hydrogen. In our last example, carbon and sulfur have the same electronegativity values, so this is a nonpolar bond. The bonding electrons are shared equally. Looking at all of our bonds, hydrogen-fluorine has the greatest difference in electronegativity, so it is the most polar bond.